In this video, we show you the functions for measuring human vibration on the VM80 and VM100 analyzers. The handy instruments are operated in a simple and intuitive manner via touchscreen. The human vibration module can be activated by purchasing a software license. It supports up to 9 measurement channels. Human vibration is the effect of mechanical vibrations from the environment on the human body. A distinction is made between vibrations that enter the body via the hand-arm system and whole-body vibrations that affect the body via seats, floors, or feet. Human vibration is investigated with regard to occupational safety and health. Comfort assessments may also be the focus, for example in road vehicles, railways, or ships. Human vibration is measured with triaxial accelerometers. Metra offers suitable sensors and mounting accessories for hand-arm and whole-body vibration. Let's take a quick look at the measurement principle. Frequency weightings that take health risks into account are used to measure human vibration. WH for hand-arm, WD and WK for whole-body vibration. For hand-arm vibration, the vector sum of the RMS values in the 3 measurement axes is calculated. For whole-body vibration, the highest of the 3 RMS values is relevant for the evaluation. Alternative methods exist. For hand-arm shock vibration, vibration peak magnitude (VPM) was introduced. Whole-body vibration can alternatively be measured as vibration dose value (VDV). Both emphasize single shock events. The instruments comply with international standards for human vibration meters. EU Directive 2002/44 specifies limit values for the exposure of workers to hand-arm and whole-body vibrations. The new EU Machinery Regulation 2023/1230 requires manufacturers to specify hand-arm and whole-body vibration values in the operating instructions for their products. In addition, information on hand-arm shock vibration is required. This is the VPM value according to ISO 5349, Part 3. Let's now take a look at the measurement screen. In human vibration mode, the screen shows up to 3 triaxial measurements. For example, hand-arm vibration can be measured simultaneously as RMS, as VPM value, and as unweighted RMS. Similarly, whole-body vibration can be measured simultaneously as RMS and vibration dose value. Unused measurands can be disabled. With a 9-channel VM100A, these can also be measurements from 3 different sensors. This makes it possible, for example, to perform whole-body comfort measurements on the seat, backrest, and foot platforms simultaneously, or whole-body and hand-arm measurements in parallel, or hand-arm measurements on 2 handles. Let's take a look at a practical hand-arm measurement. The sensor should be as close to the hand as possible, without interfering with operation. Metra offers handheld sensor adapters for this purpose. There are also adapters for attachment with cable ties. We set the instrument to hand-arm mode for sensor 1. Before starting the measurement, press Reset. This deletes any previously measured signal components. A reset can also be triggered by an electrical impulse at the RPM input. If desired, you can save the measured values every second to a CSV file on SD card. A start delay and a storage duration can be entered. The measurement duration should be at least 20 seconds and represent a typical exposure. The three displayed axis amplitudes and the vector sum are interval RMS values. This means that they are averaged over the entire measurement time. The values become more stable the longer the measurement lasts. After a sufficient measurement time has been recorded, press stop to end the measurement. The last interval RMS values and the vector sum are retained. In contrast to the measured interval RMS values with an averaging time of 1 second are plotted in the diagram. The plot diagram therefore also shows rapid signal changes. However, it is also possible to display the maximum values or vector sums in the plot diagram. If overloads occurred during the measurement, this is indicated in red until the next reset. The measurement should be repeated in this case. The signal shape button opens a window with an oscilloscope-like display of the three measurement axes. This makes it easy to see, for example, whether a signal is being clipped. The signal shape window can be moved and resized. The smiley symbol indicates how long it would take with the currently measured vibration to reach the EU exposure limit. The exposure limit specifies the maximum permissible vibration exposure for an 8-hour work shift. The smiley can be green, yellow, or red. Touching the smiley symbol opens a menu for entering the time limits for the three colors. In the example shown, the smiley will turn yellow if the exposure limit value would be reached in less than 2 hours, and red if it would be reached in less than 1 hour. This would mean that the activity currently being examined may be performed for 2 or 1 hour per 8-hour shift. This button opens a text window showing the time until reaching the EU exposure action value and the exposure limit value with the currently measured vibration. This allows for a quick assessment of the vibration just measured in terms of its potential health risk. The procedures just demonstrated are identical when measuring whole body vibration. Finally, let's take a look at the stored measurement data. Spectra can be stored on the device's SD card as a bitmap screenshot or as a CSV measurement table. The suggested file name consisting of date and time can be changed if necessary. The analyzer has a read function for NFC tags to identify measurement points. These contain a unique identifier that can be linked to a descriptive text. The saved CSV files consist of a header with data on the measuring device and the connected sensors, as well as the settings for each measurand. The actual measurement data, each point consisting of timestamp, interval RMS and 1 second RMS for each sensor axis, plus maximum values, vector sums etc., begins in line 22.